Okay. Good evening. Can you hear me? Can you hear me? Okay. Yes, right. Okay. Okay. Last week we discussed complete the lesson, right? The okay. This is the uh, past exam questions. All questions from kinetic chemistry lesson. Okay. Before these questions, any doubt in last week paper? Any doubt question? We can discuss now because today we have time, we have 2 hours for discuss any doubt in kinetic chemistry, because this kinetic chemistry very important. That's why I take this time. If not, we can start today work energy power. Let's start next week. Okay, first complete this lesson, kinetic chemistry. Okay, before this question, before this one, where is our last week paper? Have we discussed all questions? Yes, right. ඔක්කොම කරලා නේද? Kabir, have we discussed? All completed, right? ඔක්කොම ඉවරයි නේද? All completed, right? Okay. Let's move into MCQ part. Okay, question number 1. Question number 1 actually thermal chemistry. No? Thermochemistry. The amount of heat generated is 604 kilojoule. It's a mistake, as mistakenly it came for this paper. However, now we have already completed thermochemistry as well. Okay, you can do it. Okay, the amount of heat generated is 604 kilojoule when 12 gram of ethylene, ethylene is C2H4, ethylene gas C2H4 is combusted. The molar mass of ethylene is 28 gmlo minus 1. The balance equation for ethylene combustion is given below. Okay, what is the balance equation? C2H4 react with oxygen, then it is produced carbon dioxide plus water vapor. Carbon dioxide plus water vapor. Okay. For thermochemistry or kinetic chemistry, any question, what is the first step? Balance the given chemical equation, right? Balance the given chemical equation. Then how to balance this? Now the question given balance equation. Okay, now it is balanced. Now it is balanced. Now it is balanced. Okay, this is the balanced chemical equation for given ethylene combustion. Balanced chemical equation for ethylene combustion. Okay, now this question given the amount of heat generated. Now the question asks the heat of reaction. The heat of reaction asking. Directly the question is heat of reaction. Heat of reaction calculation we did. We practiced several lot of questions. Okay, what's the meaning of heat of reaction first? Heat of reaction mean heat of reaction. Heat of reaction. The quantity of heat Q over reacted number of moles. Quantity of heat mean, is it endothermic reaction or exothermic reaction? Joel, the given reaction exothermic or endothermic? Quickly. Now they are very simple things. Is it a exothermic reaction or endothermic reaction? Yes, definitely it is exothermic. Why? It is a combustion reaction. I told all combustion or burning reactions are exothermic. Then no need to write down quantity of heat. We can say directly the amount of heat release, no? The amount of heat release, that's a quantity of heat, amount of heat released divided by reacted number of moles. Reacted number of moles. Reacted number of moles. Okay, this is the basic equation for heat of reaction. Okay, now the question asks ethylene combustion heat of reaction. Ethylene heat of reaction for ethylene combustion. I told in heat of reaction lesson we can get heat of reaction for ethylene combustion as well as oxygen combustion. For all reactants we can calculate. Okay, but in this question asks only for ethylene combustion. Okay, the amount of heat generated is given here, right? The amount of heat generated when react 12 gram of ethylene. Then the amount of heat released to the environment, it is given 604 kilojoule. 604 kilojoule we can convert into 604,000 joules. 604,000 joules. 604,000 joules. Okay, now you want to calculate number of moles reacted in ethylene. Ethylene reacted number of moles. Okay, how to calculate the number of moles? Molar mass given. What is the molar mass? Sorry, mass over molar mass, right? This is our basic equation, mass over molar mass. Mass over molar mass. I told number of moles calculations, there are two main types in our syllabus. Using molar mass and concentration. Concentration එකෙන් හදන්න පුළුවන්, molar mass එකෙන් හදන්නත් පුළුවන්. This is molar mass part. Okay, N equals M over capital M. Mass over molar mass. Mass over molar mass. Okay, what is the ethylene mass? Mass of ethylene 12 gram. Only 12 gram. 12 gram. 12 gram. Molar mass is given, right? Molar mass given, it is 28, right? 28 GMOL minus 1. 28 GMOL minus 1. 12 and 28. 12 over 28, what is the value? 6 over 14. 3 over 7. Can you send me the decimal value? 12 over 28. Dihini? 12 over 28. 0.42. Great. 0.42. 0.42 moles. 0.42 moles. Okay, this is the reacted number of moles. Reacted number of moles. Okay, now what is your next step? You found not reacted number of moles. You found ethylene number of moles, ethylene moles, and the amount of heat released to the environment, right? Okay. Now, what is the next step? You have to consider about stoichiometric ratio. You have to consider about stoichiometric ratio. Okay, now this is the stoichiometric ratio. Stoichiometric ratio 1 to 3. 1 to 3 is the stoichiometric ratio. 1 to 3 is the stoichiometric ratio. Now I told number of ethylene 0.42. 0.42 moles, and oxygen is any in normal environment, anything burning. Tell me oxygen is limited or unlimited? Oxygen unlimited, not limited. In a covered container can be oxygen unlimited, oxygen limited, but this condition, ethylene burning in normal environment, oxygen unlimited, oxygen unlimited. Therefore always according to stoichiometric ratio, according to its stoichiometric ratio, to completely burning this all ethylene, 3 times of oxygen, 0.42 into 3, 0.42 into 3, what is the value? 6, 1.2 1.26 moles of oxygen required. 1.26 moles of oxygen required, that can given in the environment. Okay, why? Oxygen not limited now. Okay, now then we can decide all ethylene added for this reaction is reacting. හරිද? ඔක්කොම ටික අපි දාපු ethylene ඔක්කොම මොකද වෙන්නේ? react වෙනවා. What is the reason? Oxygen unlimited. If it is not oxygen unlimited, not all ethylene reacting. Okay, can you understand what I explained? Okay, oxygen unlimited නිසා තමා මෙයා all reacting. Okay, then reacted number of moles 0.42 moles. 0.42 moles. Okay, this is answer. Send this answer. JMOL -1, but I think answers given in kilojoules. Answers given in kilojoules. Now you can convert into kilojoule. Kilojoule. Okay. What is the answer? Oh, I think it's a mistake because of our decimal points. Okay, let's divide 3 and 7. 3/7. Yeah, if you use as a fraction, I think we can get an answer. Yes. Yeah, this is the method. If you got, because 12/28, not actually 0.42, right? Am I correct? It is a long value. It is long decimal value. Then if you got 0.42, answer is not matching the answer with given answers. Now you can use a trick. This is a trick. Now answer asking kilojoules. Okay, therefore you can use kilojoules. 604 kilojoules, no problem, because answer is given in kilojoules. Okay, now then this is not the actual answer, no? This is not the actual answer. It's a long value. Okay, therefore what we can do, we can use as 3/7 as a fraction. Okay, 3/7. 3/7. Okay, now you can get the accurate value 604 kilojoule multiplied by 7/3. Multiplied by reciprocation. You can get the answer 1409 kilojoule per mole. Okay, check your answers. Okay, use calculators and check. Is it correct? Kabir, check this answer. 604 into 7/3. Yes, correct. Okay, they are the tricks in exam. Okay, if you use as a fraction, you can get the accurate answer. Okay, this is the answer number 4. Okay, who correct this question? This is from last lesson because already completed. Okay, who correct this? Before that, why these all answers minus? Fatima, why those all answers minus? All answers minus, right? What's the reason? Amina, what's the reason? No. Reactant product story එකක් නෙවෙයි තියෙන්නේ. It's not a reason. This is from last lesson. Thermochemistry. Okay, if we're learning kinetic chemistry, you can't forget everything about thermochemistry. Okay. What is the reason? Yes, Dini, correct. Others, Fatima, Kabir, what is the reason? Why these all values are minus answers? Heat of reaction values are minus. Dihini? Yes. Yes, because of this, the reaction is exothermic reaction. I told in thermochemistry lesson, you can't, don't forget thermochemistry now. I told this thermochemistry, kinetic chemistry, industry chemistry, natural products, environment chemistry, they are the key lessons in exam. Don't forget anything. Continuous, but yes, they are easily forget, because when you learn new thing, our normally our brain is made, if you not use continuously any theory or any concept, they try to forget it automatically. Otherwise, we can't store everything. What you can do, you have to revise every time. Okay, you can go through again after 2 to 3 days. You have to go through again thermochemistry. After this biomolecule, if you can remember everything now, after 2 to 3 weeks, in mid of January, if I give you the question, you can't remember. Okay, that's the nature of our brain. It is not a your problem. Okay, everyone, that's the nature. What you can do, you can revise every time. After 2 to 3 days, you can revise. Okay, I will explain in our revision class how to now, from January month, how to start your working and how to manage and time management and everything, how to make a schedule for final 6 months, everything. I hope to get a special meeting in first week of January after New Year break. Okay, the reason I told heat of reaction for exothermic reaction always minus. Yes. Heat of reaction for endothermic reaction always plus, always positive, always positive. This is an exothermic reaction. That's why it is minus. Who correct this question? Raise hand. Question number 1. Only one? Okay, good. The correct statement related to the rate determining step of reaction is rate determining step of a reaction. It is the fastest step of multi-step reaction. No, fastest step not determine the rate of reaction. Always first step of multi-step reaction. No, always the last step of multi-step reaction. We can consider about this. Not affected by catalyst. Catalyst is a main factor. The slowest step of multi-step reaction. Okay, that's the most accurate answer. I told it is a theory. It is a theory. Direct theory question. In the lesson, in the note, I have given. In multi-step reactions, the rate determining step always what? Slowest step. Slowest step. In a marathon competition, I already explained. Do you remember? In a marathon competition, I told this is the starting point, this is the finishing point. A, B, C, D. A, B, C, D for child participate for this competition. Then what? Who determined the final time consumption for this entire game? the slowest man, the slowest boy, the slowest child. Again, him the final time, the end of this game determined by the slowest child. Okay, same. The rate of reaction also, the slowest step determine the rate determining step of the multi-step reaction. Okay, answer number 5. Okay. Activation energy of the forward reaction. Okay. In the lesson, I discussed about forward reaction, right? In the theory part, forward reaction mean reactant convert into product. What's the meaning of backward reaction? Backward reaction mean or reverse reaction backward reaction or reverse reaction, product again convert into reactant. Reverse. This is the backward reaction. Sorry, this is a forward reaction. This is a backward or reverse reaction. Product again convert into reactant. If you got reverse reaction in the forward reaction, product, in the reverse reaction, reactant. Okay, that's a simple thing. Reactant convert into product. In reverse reaction, product convert into reactant. Okay, the activation energy. Okay, tell me. Okay, is this reaction exothermic reaction or endothermic reaction? Is this exothermic or endothermic? Vihlan, is this reaction exothermic or endothermic? Very good. Others, Yumidu? Is it exothermic or endothermic? Okay, now they are very simple things. Now reactant energy level greater than product energy level, right? Then it is always exothermic reaction. Why it is less than product energy less than? Because some energy released to the environment. Okay, now actually what is the activation energy? Now this question asks the activation energy of the forward reaction. Activation energy of the forward reaction shown in the energy diagram. Okay, the activation energy, what's the definition of activation energy? The minimum energy of reactant to participate to the reaction. The minimum energy of reactants to participate to the reaction. Okay, always in this energy diagram, the activation energy calculate from reactants. Okay, this is the activation energy. Okay, this is activation energy. Let's consider about answers. Okay, E3, it's not the activation energy. E3 mean the full height. It is not the activation energy. E3 is not the activation energy. E3 minus E2, yes. E3 minus E2 mean this. Yes, it is correct. E3 minus E1, this is a product energy. Product to activation energy. It is not the activation energy. E3 plus E2. No, E3 plus E2, it's a greater value. E3 plus E1, no. Answer number 2. Who correct? Raise hand. Good. Consider the following statement regarding catalyst. Yeah, catalyst is the main factor affect to the rate of chemical reaction, right? They always exist in solid state. They always exist in solid state when they are active. Correct or false? Is it correct? They always exist in solid state. Correct? True or false? No, they not always exist in solid state. All physical state possible. They increase the reaction rate. That's okay. Catalyst increase the reaction rate. Okay. They are altered the chemically at the end of the reaction. True or false? They are altered chemically at the end of the reaction. Okay, this is a point. Amina, statement number C, true or false? Yes, altered mean actually changing chemically vary or changing. No, catalyst not always chemically changing. Yes, I explained in the lesson, catalysts are always at the end of the reaction, they are not chemical, not any chemical change. They are not involved for the reaction. It is only decrease the activation energy and it's only help. The catalyst is only help, not involved for the reaction. If it is involved, it is not a catalyst, it is a reaction, it's a reactant. They increase the activation energy of the reaction. Completely wrong. What is their function? They decrease the activation energy. Decrease activation energy. Answer B on. Who correct this? Dihini correct? Okay, great. The decomposition of NO2 can be shown as follows. The decomposition of NO2, nitrogen dioxide, can be shown as follows. Okay, this is nitrogen dioxide, NO2 decomposition. Okay, the balanced chemical equation is given. Okay, which is true regarding the above reaction. Above reaction. Production rate of NO, nitrous oxide, no, nitrogen monoxide, NO. Okay, there is a difference. That's the nature difference, right? The reason we discussed delta. Do you remember we discussed delta NO over delta T? The same thing. They have used C letter for concentration. C for concentration, that's only difference. Okay, that's a different method. Okay, in our syllabus given this method, they have asked in another method. Okay, now you can understand this method as well. Okay, it is same. Okay, the C mean concentration. Now delta concentration, delta mean change, concentration change of NO divided by delta T. Concentration change of NO over delta T. Okay, the production rate of NO, tell me The first statement is correct or wrong? The production rate of NO minus delta C NO over delta T. Is it correct? Okay, wrong. Yes, Joel correct. Okay, what is the mistake? What is the wrong point? Why it is wrong? Timidu, why it is wrong? Very good, Rehla. The production rate of NO mean NO concentration change divided by time. NO concentration change mean delta CNO over delta T. That's only. No any minus or any value required. This is the NO production rate. It is completely wrong. It's completely wrong. Okay, production rate of NO again given. Now it is correct, right? It is correct. It is correct. The reaction rate decrease with the temperature increase. The reaction rate decrease with temperature increase? No. Completely wrong. The reaction rate increase with temperature increase that we discussed. Wrong. The concentration of NO2 gas, nitrogen dioxide gas, has no effect on the reaction rate. The reactant concentration is a main factor. It has effect. It has effect. When the pressure of NO2 gas decrease, the reaction rate increase. No. Directly proportional. Pressure increase, pressure decrease, reaction rate decrease. Okay, answer number 2. Okay, next one. 2017. The decomposition of chlorine oxide, potassium yes, KClO3 can be shown by following reaction. Okay, KClO3. The problem I can't. It is clear for camera, but normally it is blur. Now okay, right? Okay. Are you clear these letters? Or not? For camera, I think clear. Yeah, for camera, no problem. Before this, did you see last night there was a issue for airplane? Did you see this news? දැක්කද? Airplane එක දැක්කද? Okay, what's the problem came for this? The problem is these landing wheels. Normally, airplane in fluid mechanism, we fully discussed about this airplane. Okay, in fluid mechanism lesson. Okay, normally this is the shape of airplane. This is the shape of airplane. This is the shape of airplane. Normally, it is the shape of fish. This is the shape of normal shape. If you got a cross section. Okay, now the wind. Do you know how to lifting a airplane? Normally, airplane lifting not by any external power. It is mainly due to the wind power. Wind එකෙන් තමයි උඩට යන්නේ. Okay, it is like this. Normally, can airplane එකපාර මෙහෙම උඩට ගන්න පුළුවන් like a helicopter? එකපාර? No. It should have maintained a certain speed. Speed එකකට ආවන් තමයි gradually it's lifting up. Okay, normally the reason when increase the speed in ground level, when increase the speed of this airplane, what happened? This air flowing speed due to this shape, air flowing, air කියන්නේ මෙන්න මේ shape එක. Due to the shape of the airplane, okay, the cross section shape of the airplane. Okay, but in lower level of airplane, it's no any issue. In the lower side, no any issue. Okay, normally we have a special theory as Bernoulli's theorem. Bernoulli's theorem. According to this Bernoulli's theorem, we can discuss in fluid mechanism lesson. When increase the air flowing speed, according to Bernoulli's theorem, when increase the air flowing speed එක වැඩි වෙද්දී the pressure is decreasing. But now what happened due to the shape of the airplane in upper side? This side, what happened? The air flowing speed is greater than this side. Okay, that's the reason. They we called as streamlines. May streamlines very close. When increase the speed, these streamlines getting very close. Okay, may what we can streamlines here. Okay, in fluid mechanism lesson we can discuss. Okay, these streamlines getting close in the upper side, and air flowing speed is greater on the upside of the airplane. Uda side. Due to this region, the pressure is getting low. In higher velocity, pressure is getting low due to this high velocity. But in lower side, normal air flowing speed. මෙතන මොකුත් change එකක් වෙන්නේ නැහැ. These streamlines are same gap. Therefore, they are in normal pressure. Comparatively velocity less, and pressure greater mean pressure normal. Okay, normal atmospheric pressure. Okay, now you can see it is high pressure and low pressure. There is a pressure difference is exert on the airplane. Pressure difference. Due to this pressure difference, a force is exerted on the flat layer of this bottom. Make a matter. Force exert වෙනවා on this area. A force is exerted due to this pressure difference. That's why gradually it's lifting when come to its required speed. May speed එක maintain කරන්න ඕනේ. මේ pressure difference mainly depend on the speed. This pressure difference mainly depend on the speed. Okay, due to this pressure difference, what happened? A force is exerted on the flat lower level, flat lower side. Okay, may flat indicate force එකක් exert වෙනවා. Okay, that's the reason for lifting an airplane. Lifting an airplane. Okay, now what's the problem? Last night, this mechanical issue. The mechanical issue mean there are wheels. මේක තියෙනවා මොනවාද landing wheels. For landing they need wheels, no? Normally lot of wheels. They have lot of wheels in airplanes. They are, if we can see very small wheels, they are very low, large wheels, right? Large and heavy wheels. Heavy wheels. But when it is just lifting, airplane එක ඉස්සෙද්දිම what they doing? They need to enter into, they hanging into a container and close this container. Make a මෙහෙම ඇතුළට ගිහින් මේක close වෙන්න ඕන. Because the reason, the lower level of the lower side of the airplane should have smooth line. If there are any disturbance for this air flowing, this type pressure also decreasing. මේ side එකේ pressure එකත් අඩු වුණොත් it is disturbing for this pressure difference. Then what happened? Due to this landing wheels, the airplane fall down. Okay, the reason for last day mechanical issue, this landing wheels not go to inside. Landing wheels not go to inside. That's why normally airplane when they start their journey, they carry lot of fuel weight. According to their distance, they store and they store with additional fuel also. Okay, the problem, whatever accident or whatever mechanical issue, if they need to land this airplane suddenly, the problem, with this fuel weight, they can't land directly. That's why they try to burn part of this fuel and try to safely land. Okay, that's the story. Okay, ඒක නිසා අපි මෙයාට එකපාර land කරන්න ඕනට with this fuel weight they can't land safely. It is not a safe protocol. If they need to land, what they have to do? They have to burn part of fuel in part එකක් burn කළා තමයි suddenly landing එකට යන්න පුළුවන්. Okay, this is this type normal practical things, they are very important for exam. That's why I explain. If you after we learn fluid mechanism lesson, we can get the full idea about Bernoulli's theorem and this story, because this type practical scenarios very important. Lot of exam questions, mainly physics part questions in the exam paper, based on this practical scenarios, practical actually day-to-day life news and applications. Okay, I got this story or not? Okay, I know you can't understand 100%, but I explained a little bit for you. In fluid mechanism lesson, we can discuss in with 100% idea we can discuss. Okay, can you understand that මෙතනත් disturbance එකක් තිබ්බොත් what happened? With this disturbance, this pressure difference cannot maintain. for this pressure difference maintain, it should, the lower side should be a smooth side, smooth, and this side high airflow, low pressure and high pressure. That side it has a pressure difference. Okay, that's about fluid mechanism. Okay, 6. The decomposition of potassium chloroxide can be shown in the following reaction. Okay, KClO3 convert to potassium chloride plus oxygen gas. A heated sample of KClO3 has produced 5 moles of oxygen in first 5 minutes. 5 moles of oxygen in first 5 minutes, and another 3 moles of oxygen in the next 5 minutes. First 5 minutes it's produced 5 moles of oxygen, and in the second 5 minutes it's produced next 3 moles of oxygen. What is the average decomposition rate of potassium chlorate in that 10 minutes? What is the average decomposition rate of ClO3? Five moles of oxygen in the first 5 minutes, and another 3 moles of oxygen in the next 5 minutes. Okay, first we can find average production of oxygen, right? Oxygen. But the question asks, what is the average decomposition rate of KClO3 within this 10 minutes? Okay, before this calculation, the heated, now the equation already balanced. KClO3 has produced 5 moles of oxygen, 5 moles of oxygen and 3 moles of oxygen. Now overall 8 moles of oxygen is produced, right? 8 moles of oxygen is produced. How many, what is the time? Time 10 minutes. Time 10 minutes. Time 10 minutes. Okay, now 8 over 10, it is 0.8 mol per minute. Mol per minute is the mol per minute is the average rate of oxygen production. Oxygen production rate is 0.8 mol per minute. Okay, again go to question. Okay, let's write down our equation first. 2 KClO3 2 KCl plus 3 O2. Okay, now the oxygen production average rate is, 0.8. That means delta O2 over delta T equals 0.8 mol per minute. Per minute. Don't think about unit. According to the given data, we got the unit. Okay, but the question asks KClO3 decomposition rate. Okay, what's the method? Very simple. As we discussed in the lesson, minus half delta KClO3 over delta T. This is the asking in the question. The Metron name, this is MCQ question, but I am explaining for full as a If it is a structured question or essay question, I am explaining with full explanation with all steps. Okay. It is 1/3 delta oxygen over delta T. Okay, it is minus half delta KClO3 over delta T equal 1/3. Oxygen production rate is given 0.8. 0.8. No need unit. We can use the unit later. Okay, now our requirement is KClO3 product decomposition rate, right? Okay, now what we can do, both side multiply with -2. Both side multiply with -2. Then -2 to -2 cancel out. Multiply karna -2. Now what happened? 1.6/3. Answer number 4. Okay, it is actually minus value, but all answers given positive values. No? See, what is the average decomposition rate asking? I told decomposition decaying rates always minus, but they given positive values, but no problem. Okay, who correct this? This is a very good question, right? This is a very rational, very standard questions. කවුද හරි? Only 2. Only 3. You mean to correct, Joel? Okay. This is a very good question. Do it with steps. Step by step, you can write down. Actually, it is minus 0.53 is the answer, but all answers given in positive. That's why I select positive value. Actual value is minus 0.53. Yeah, it is same as our practice question. Only unit is different, right? Unit is no units. Ek change කරලා දෙලා නෑනේ. All answers given in same unit, right? Therefore, you don't need to think about unit. Fatima, correct? Okay, note down. It is 0.53. Actual answer is 0.53 minus, no? Minus 0.53 mol per minute. Okay. Other thing, your question understanding is very important. Again, a heated sample of potassium chloride has produced 5 moles of oxygen in the first 5 minutes and another 3 moles of oxygen in the next 5 minutes. So overall 10 minutes. Overall 10 minutes. It is oxygen production. Oxygen production. What is the average decomposition? It is asking average decomposition. Okay, first we can find average production of oxygen molecule. Okay, average production of oxygen molecule, it is 0.8. Then I substitute this 0.8 into our basic rate of chemical equation. Give me a second. Okay. Do you have any doubt of this question? It's a very good rational question. Okay, any doubt or clear? Send me message. Do you have any doubt of this question or clear? This is normal method as we discussed in the lesson, right? Rehlan, understood? Amina? Okay. Let's move into question number 7. The reaction between an acid and base can be shown in the follows. Okay, acid and base mean in the first sentence you should know it is an exothermic reaction. Okay, acid base all reactions are exothermic. No? Okay. Now the amount of heat generated, that one also thermochemistry, no? The amount of heat generated when 100 milliliter of HCl acid reacted with an excess amount of sodium hydroxide, excess amount that we discussed, right? Excess amount of sodium hydroxide is 5.57 kilojoule. Okay. The concentration of the HCl solution. Okay. The other very important thing, this is the reaction OH minus react with hydrogen plus, then it is made H2O water. But there is another data given here. 55.7 kilojoules per moles. What is this? That is the heat of reaction. You can understand this by unit. 55.7, that is the heat of reaction of this reaction. Heat of reaction. Heat of reaction. The amount of heat generate, yes, generate heat, exothermic. When 100 milliliter of HCl, 100 milliliter of HCl, as it reacted with an excess amount of sodium hydroxide. Excess amount of sodium hydroxide means sodium hydroxide unlimited. It is not limited. Then limited one is HCl. Limited one is HCl. The reaction take place until only complete the HCl. Okay, that's a store. Okay, now the heat of reaction. Heat of reaction equal quantity of heat divided by reacted number of moles. Reacted number of moles. The quantity of heat, the heat of reaction given 55.7. 55.7 JOKJ, kilojoule, I think, right? Yes, kilojoule MOL minus 1 per mole. 55.7 of kilojoule is made. Kilojoule is released. The quantity of heat given while reacting 100 milliliter of HCl, 5.57 kilojoule is released or generate. 5.57 kilojoule is released. This is a quantity of heat release amount. The next we required the number of moles of HCl. Number of moles of HCl. Okay, how to calculate number of moles of HCl? The concentration of the solution is asking. The concentration of solution asking. Okay, now first you can find the number of moles in this reaction. You can find number of moles. Reacted number of moles. Reacted number of moles. Okay. Now isolate the N. N equal 5.57 kilojoule divide by 55.7 kilojoule MOL minus 1. Okay, kilojoule to kilojoule cancel out. 5.57 over 55.7. What is this? It is 1 over 10, right? 1 over 10. If you can't see as 1 over 10, you can use calculators. Okay, then N equal 0.1 mole. 0.1 mole is the N. But the question asks HCl concentration. Concentration equal number of moles divided by volume. That's a basic. Concentration is the number of moles in a unit volume. Number of moles in a unit volume. Now the concentration equal number of moles 0.1. 0.1. Volume is given. The concentration, the volume of the HCl is 100 milliliters. To convert into cubic decimeter, divide by 1000. Divide by 1000. This is full cubic decimeter. Now 20 cancel out. 0.1 over 1 over 10 means 0.1. Answer equal 1 MOL dm minus 3. Answer number Please do it one by one. Okay, who correct this? Good. Okay. They are very advanced questions and standard questions, right? Only for student. Amina, correct? Fatima? Ah, correct. Okay. Okay. Question number 8, 2018. Activation energy for the given reaction is. Okay, send this answer number. It's a theory question. Yes. The activation energy, the definition of activation energy asking, right? The average energy of reactants, no. The average energy of reactants at 25 Celsius and atmosphere, no. The energy difference between reactant and product, it is not the activation energy. The minimum amount of energy required to initiate the reaction, yes. That's the most suitable one. The amount of energy released by reactant, no. 2019. The activation energy of a reaction depend on, see, again asking same thing, not same factors. The activation energy of a reaction depends upon heat supplied. By heat, activation energy, no effect. But in heat supply, කරාම මොකද වෙන්නේ? The amount energy level of reactants increasing. Therefore, activation energy exceed number of molecules increasing. Like this. In supply of heat energy, what happened? This reactant molecule heat energy increasing. Think ABC, reactant molecule 10 joules, 11 joules, 12 joules. Their energy level increase, but activation energy is the same value. Activation energy can't be changed with heat energy. It is 11 joule, it is same. But the reactant energy level of molecules can be increased. Okay, they are very important things. The pressure, by pressure is not effect for the activation energy. Reactant concentration, no effect. Mixing speed, no effect. Catalyst are the effect. Catalyst are the effect for the activation energy. 2020, the rate of reaction of a multi-step reaction always depend on, multi-step reaction always depend on, same as previous question, but it don't have slower step, no? But it don't have slower step. Okay, now what do you think? What is the answer according to given answer? What's the most suitable answer? The rate of reaction of multi-step reaction always depend on, according to given answers, always. Okay, always very important. Always depend. Always depend. Volume of reactants. Not always depend. Temperature. Not always we can't say. Number of reactants. Number of step of the reaction. Rate of the fastest step of the reaction. What do you think? Okay, that's a very good rational question. What do you think? Others, what do you think? Now, actually, the most suitable answer is not given. Actually, according to our syllabus, according to our teacher's guide, the slowest step of the reaction is the rate determining step. But it is not given in answers. Now, the question asks, according to given answers, the rate of reaction of multi-step reaction always depend on the number of steps. If it is high number of steps, if it is more number of steps, what happened? The rate is less. If it is less number of steps, greater it is a speed up. Okay, final question. Consider the following reaction. It's a very good question. Consider the following reaction. It is H2O2 decomposition reaction is given. Hydrogen peroxide decomposition reaction. H2O2. H2 plus O2, right? H2 plus O2. Okay, first balance this chemical equation. 2 hydrogen. Sorry, H2O. Now 2 hydrogen, 2 hydrogen. Oxygen not balance. Oxygen, how to balance? Oxygen 2, oxygen 3. Now oxygen 4, oxygen 4, right? Hydrogen 4, hydrogen 4. Now it is balanced. Now it is balanced. Okay. Now, okay. What do you think? What do you think? The rate of reaction is equal to the, sorry, what is the correct statement? Correct. Correct statement regarding the above reaction. The rate of reaction is equal to the rate of reaction. Rate of reaction mean R. The rate of reaction is equal to the rate of production of oxygen. Rate of production of oxygen. See, oxygen. The R equal delta stoichiometric value of 1 over delta T. This is correct, right? R equal to this one. This is the oxygen production rate. It is correct. Okay. Okay. The make a first එකම දීලා තියෙනවා luckily. But now don't think about this is the answer. Now don't think about the answer. Okay, let's see why other answers are wrong. Okay, it is very good. The rate of consumption of H2O2 is equal to the rate of production of oxygen. But what? The rate of consumption of H2O2. Consumption means decay. Rate of consumption of H2O2 is equal to the rate of production of oxygen. See, oxygen, මේවා හිතන්න ඕනේ. Then you don't need to calculations. Oxygen stoichiometric value 1. H2O stoichiometric value 2. Then the decaying rate of H2O is H2O2, hydrogen peroxide, not equal to oxygen. It cannot be. Okay, it cannot be equal. Okay, therefore second one is wrong. Okay, it's easy. But third one, the rate of production of oxygen is greater than the rate of consumption of H2O2. Okay, tell me how to get this, how to prove this. Actually, it is wrong. How to prove this? How to identify? How to identify? Okay, I can give you 1 minute and can you prove this? I need with expressions. Okay, sorry. Okay, how to prove this? How to prove this now? First statement correct, but if it is given prove this part as the rate of consumption of the rate of production of oxygen is greater than the rate of consumption of hydrogen peroxide. Okay, this is the method. This is the method. The question given, the answer given, oxygen production rate greater than the consumption of, it is greater than the consumption of H2O2, right? Okay, let's see. If you got relationship between oxygen and hydrogen peroxide, it is minus half H2O delta H2O2 over delta T equal delta O2 over delta T. Okay. Think the hydrogen peroxide as example, if you think H2O2 decaying rate is 10, think H2O decaying rate 10, the value is 10. Then what is the O2 production rate? O2 production rate only 5, see. If it is 10, O2 production rate only 5 because 10 over 2. 10 over 2, it is 5. Now it is wrong. The oxygen production rate not greater than H2O2 production rate, decaying rate, sorry. Are you complete? Are you clear or not? Udanya, are you clear? May? If it is 10, it is only 5. Clear or not? Rehlan, clear? Habir? Okay, it is very simple thing. It is actually hydrogen peroxide decaying rate double than oxygen production rate. It is twice. Okay. Therefore, third one is wrong. Okay, let's move into fourth one. The rate of production of oxygen is equal to the rate of production of H2O. H2O and oxygen stoichiometric value difference. Therefore, cannot be equal. Wrong. Easy. But final one, the rate of production of oxygen is greater than the rate of production of H2O. It is same. Now we can get a relationship between H2O, right? H2O over delta T equal delta O2 over delta T. Same thing. If you got H2O production rate 10 minus half, minus 10, then minus plus, it is 5. The oxygen production rate only 5. Then it is not greater than. It is less than. Answer number 1. Okay, any doubt? They are the exam questions. Okay, if you have any doubt, you can ask about kinetic chemistry or thermochemistry both. Okay, if you don't have any doubt, quickly move into 2016 2016 paper. Before next week, you have to get, you all need to get printouts of all past papers. Past papers ටික ඔක්කොම ගන්නද? You can download all past papers in our link, okay, website, and take printouts. No need mark schemes, only papers you need. Okay, come to question number 2. Okay, question number 2, 2016 question number 2. Okay, read this question. If you have printed paper, you can find it. If not, don't have, you can use this question. Okay, a fast food company has developed, yeah, it's a long story given. Fast food company has developed a self-heating cup. Self-heating means automatically it's heating, right? With a special coating to keep the coffee warmer for longer period of time. This cup also comes with a special lid to keep heat and water vapor trapped inside. Calcium oxide and water are separately placed in a chamber located at the bottom to generate heat when mixed. Yeah, calcium oxide and water mixed when required, then it is heated because it is exothermic reaction. Few cups were supplied to your school to check the effectiveness of these cups. The proposed experimental setup is shown in the figure right side. Okay, this is the lid, and in the bottom calcium oxide and water separately stored in the chamber. This is a coffee drink, and this is a special lid, and it contained with the thermometer as well. Okay, now let's go to questions. Part A, based on the matter and energy exchange, which type of system a cup of hot coffee without a lid? Again, read question. Without a lid can be classified. Send your answers. Based on matter and energy exchange, which type of system? Okay, I told mainly 3 types of system: open system, closed system, and isolated system. If you got open coffee cup, what is the type of system? Open coffee cup. Others? Yes, it is open system. Open system. It is open system. Okay, before 1st week of January, you all need to get printouts of all past papers. 2025 paper, I will send with the structured paper. Up to now 2024, you can get printouts. state two molecular level differences between liquid water and water vapor. Actually, it is liquid state and water state is molecular level differences asked, right? If you got liquid water, it is a liquid, no? Then it's a comparison differences. In differences, we can say, okay, all differences. Let's write all differences. What's the first one? Intermolecule spaces. Sorry, intermolecule bonds first. Intermolecule bonds. I'm writing in short form. Intermolecule bonds strong than vapor. Strong. Now it is comparison. Then we can say it is strong than vapor, than gas. Weak intermolecule bonds. Weak intermolecule bonds. Weak intermolecule bonds. Okay. Intermolecule space. Intermolecule space. Less intermolecule bond spaces. High. Huge intermolecule spaces. Lot of intermolecule space because molecules are freely available in water vapor. Molecules closely compact. Molecules freely moving. Okay, if we think molecule kinetic energy, it is less molecule kinetic energy. Less molecule kinetic energy, that means vibration. Molecule kinetic energy. If you got molecule kinetic energy of water vapor, it is greater molecule kinetic energy than liquid. Okay, they are the main differences between liquid water and water vapor, mean liquid physical state and water physical state differences. Okay, very simple. Okay, part B. The following chemical reaction is used to produce heat to keep coffee warm. Okay, calcium oxide react with water, then it is made calcium hydroxide. It is exothermic reaction. Okay, that's why increase the heat of the coffee. Okay, read the question. Okay, this type of structured questions, lot of structured questions based on this thermal chemistry and kinetic chemistry. The most important thing you need to remember, you have to keep this story. Now it is story you have to keep in mind in the exam time. If not, for final questions you can't answer. You have to again read previous part. If you can prepare an imaginary of this story, now this coffee you have to keep in mind. Okay, everything we discussed in the question previous A parts, very important for this part as well. It is not only separate part. Okay, it's a continuous one question. Okay, until you answer for final question of this question, this structured question, you should have to keep this story in your mind. Okay, this is a rule. Okay, now read and get some idea. When 100 gram of calcium oxide above reaction reacted with water to produce solid calcium hydroxide, the amount of heat generated is 115 kilojoule. 100 gram reactor the mechara heat. The self-heating cup is filled with 150 grams of coffee drinks and the lid with the thermometer is placed as shown in the above diagram. That means it is close by late. The temperature change with time from the start of the reaction is given in the below table. Now, assume that the specific heat capacity of coffee drink 4.3, that means 4,300 or 4.3, whatever. Okay, now this is the data temperature with time. This is the starting time of the reaction, temperature 35, normal temperature, room temperature. With this reaction, within 1 minute, it's increased up to 45 Celsius, 2 minutes 55, 3 minutes 65, 4 minutes. After 4 minutes, it's increased up to 75 Celsius. Okay, after 4 minutes, in next minute, you can understand, you can see 75 Celsius again decrease up to 74.6. Okay, what do you think? What is the reason for this decrease the temperature of the coffee drink? Anyone? Don't take time. What is the reason? I are doing. What is the reason? Joel? Anyone? No idea? After 4 seconds, until up to 4 seconds, temperature increasing. But in a next minute, 4 second to 5 second time period, what happened? Not second, minute, 4 minutes to 5 minutes time period, temperature again decreasing. Okay, tell me first, what is the reason for this increase in temperature? What is the reason for temperature increasing? Why temperature increasing? What is the reason for increase the temperature? Why temperature increase when? The reason due to reaction. Now I told it is exothermic reaction. It is exothermic reaction. Due to this exothermic reaction, the temperature of the coffee is increasing. Then, but after 4 minutes, the reaction is finished. The reaction is finished. Reaction finished. That's why the temperature gradually decrease. See, it's gradually decreasing with time. Gradually decrease. Up to this level on, it is increasing. Okay, this is the reaction time. This is the after reaction time. Okay, that's the post reaction time. Answer the following question using the given data. Calculate the temperature increase due to the heat produced by the reaction. What is the temperature increase? Temperature increase 75 to 35 Celsius. This is the temperature increase. This is the reaction time. They are very simple, 35, 40 Celsius. If in doubt, please ask. Fatima understood? Okay. Mark the energy of reactants. calcium oxide and water and product calcium hydroxide on the given energy levels. On the given energy levels. Okay. Mark the energy of reactants. Reactants mean calcium oxide plus and water. Okay. Now it is exothermic reaction. Now you already know. If it is exothermic reaction, reactant or product has more energy. Good reactant. But now you can't write it is reactant. The reactant is given. Calcium oxide plus H2O is the reactant. Product has less energy, calcium hydroxide. Reactant to product. The reaction take place, reaction to product. And if you want, you can complete this is reaction coordinate. Reaction coordinate. Okay, this is the full answer for this part. Calculate the amount of heat absorbed by the coffee drink. Calculate amount of heat absorbed by coffee drink. How to calculate? Amount of heat absorbed by coffee drink up to 75 Celsius. No? Therefore, no any physical state change. Therefore, quantity of heat equal mc theta. The mass of coffee drink. What is the mass of coffee drink? The self-heating cup filled with 150 grams of coffee drink. 150 grams of coffee drink. 150 grams of coffee drink. Specific heat capacity 4.3. If you want, I will add unit as well. 150 grams into 4.3. Now you don't need to convert them. Jg minus 1. Celsius minus 1 into 40 Celsius. 40 Celsius means temperature difference. Previous part answer. Now Celsius to Celsius minus 1 cancel out. G minus 1 to G cancel out. Now you can get the answer 150 into 4.3 into 40. But send me answer. Send you answer. $150 into 4.3. $40. Yes, 25,800 joules. 25,800 joules. Okay, next part, question part 4. Calculate the mass of calcium oxide used to build the self-heating cup. Calculate the mass of calcium oxide used to build the self-heating cup, assuming all calcium oxide in the cup is reacted with water and no heat loss to the surrounding. Okay, now what you do? Mass of calcium oxide is asked. Mass of calcium oxide is asked. Okay, now if 100 gram of calcium oxide reacted with water to produce solid calcium hydroxide, the amount of heat generated 115.8 kilojoules. Okay, see, it is very simple. 100 calcium oxide, very simple. 100 gram of calcium oxide, then it is made 100 115.8 kilojoule. That means this much joule made by 100 gram of calcium oxide. 100 gram of calcium oxide. But in the reaction, only produce 25,800 joules. That means less than 100 gram is used for this cup. Okay, this is normal. 100 gram make this much joules, but in the reaction produce only 25,800. Then always it is a small value, less than 100. Okay, now you can get the mass of calcium oxide. You can get the mass of calcium oxide. Okay, you can find how much of calcium oxide required for 1 gram. 1 gram. Sorry, 1 joule. 1 joule. 100 over. Okay, this much of calcium oxide required for 1 joule, production of 1 joule, then 25,800 required. 25,800, you can get the answer. Okay, get the answer. If in doubt, please ask. Okay, then 100 gram required for 115,800 production joules, but in the reaction only made 25,800 joules. Okay, 25,800 vitarai hadanna. Now 25,800 divide by 1,158. It is 22.27 grams. Understood or not? Dihini, are you clear? Okay, now you can understand exam questions, not very simple and normal questions. They are always some standard questions. Again, you should have some kind of standard knowledge for answer this type question and understand these questions. Okay, that's why I explain you have to continuous work with this 7 months with consistency. Consistent working is required at least 6-7 months to do this game win. Okay, Dihini understood? Fatima? Ehlan? Amina? Okay, next part 5. Given relevant step. Okay, again try these questions. They already discussed very simple questions. The giving relevant steps. Calculate the average rate of temperature decrease. Calculate the average rate of temperature decrease. Average rate of temperature decrease of coffee in the cup Celsius per minute. Celsius per minute for the last 10 minutes. Okay, find last 10 minutes. Last 10 minutes in the table. Last 10. 5 to 14, right? Metana pahai. Final 10 minutes. Final 10 minutes. Okay. How about the temperature difference? Temperature difference 70.8. 74.6 minus 70.8. Relevant steps, very important. Calculate the average rate of temperature decrease. Now, rate of temperature decrease equal rate of temperature decrease equal temperature change. They are the steps. Temperature change, delta temperature, no? Temperature change divided by time. This is the meaning of rate. Okay, now temperature change means final temperature minus initial temperature. Final temperature is 70.8, 74.6 initial temperature. Final 10 minutes, no? Last 10 minutes, no? 70.8 minus 74.6, right? Divide by 10 minutes. 10 minutes. This is Celsius. Okay, send your answer. Values. Yes, correct. It is minus value, definitely, because temperature decreasing. Okay, Kabir, what is value? Minus 0.42, right? Minus 0.42. Clearly mention the unit, minus 0.2 Celsius per minute. Celsius divided by minute. Okay, this is the average rate of temperature decrease. (0.42). What is the time taken to complete the reaction between calcium oxide and water? Time consumption, what is the time taken? Time taken only 4 seconds. Only 4 seconds. 0 to 1, 1 minute. Sorry, 4 minutes. 0 to 1 minute. Metana ekai. 1 to 2 minutes. 2 to 3 minutes. 3 to 4 minutes. Only 4 minutes take place for reaction, because temperature increase only up to 4 minutes. 4 minutes. With the relevant step, calculate the average consumption rate of calcium oxide in grams per minute. Can you calculate? Relevant step, calculate the average consumption of calcium oxide. Okay, consumption of calcium oxide. Now we have to think all calcium oxide is consumed. Okay, in previous part I found 22.27 is the calcium oxide gram, right? Okay, now calcium oxide decaying rate or consumption rate equal calcium oxide mass change, calcium oxide mass change over time. This is the steps. They are the steps. Okay, calcium oxide mass change in final mass is 0 because all calcium oxide is reacted. Minus initial gram, it is gram වලින් තමයි අපි දාන්න ඕනේ. Initial gram 22.27. Previous answer 22.27. 22.27. Divide by how many time consumed in previous part I got 4 minutes got. 4 minutes got. Okay, it is gram 4 minutes got for this process. Okay, clear. You should. Okay, now I want to explain here. They are not too advanced questions. They are standard questions. Okay, you should have to improve this, understand this type and this type question and answer in confident level. You should have to improve your knowledge and practice them. Okay, that's a requirement of explaining this type standard questions. Okay, now minus 22.27 divided by 4. Send your answer. Minus value. $5.56. 56 G minus, okay, minus 5.56 G grams per minute. Grams per minute. Grams per minute. Minus 5.56 grams per minute. Okay, any doubt of this question? Any unclear part? Dihini, Fatima, Kabir, Amina, Jumidu? Any unclear part? No, right? Kabir? Okay, that's the officially end of kinetic chemistry. These 3 lessons, මේ තුනම අපි ඉවරයි. Heat, thermochemistry and kinetic chemistry, all 3 lessons officially completed. Now next week, next Tuesday, you have an exam, our revision class number 1, exam number 1. Please ready. Tuesday mean what is the day? Tuesday mean 23, no? 23, 23rd. Okay, 24th, you don't have class. 24th, Christmas holiday. After that, we start first week of January, the work, energy and power. The work, energy and power tute and your revision tute pack of January tute pack, I will send you at the final week of December. In Christmas week, I will send you a tute pack, work, energy, power tute and January tute pack of the revision class. Okay, and yes. Sorry, not work, energy, power. Work, energy, power we start for 27. Work, energy, power we did for 26, no? I forgot. Okay, next week we start electricity, sorry. Electricity. Okay, today I will send you what are the lessons we complete and what is our future plan to cover other remain lessons because we have limited time. At least May to June, second week of June, we have to complete all lessons and go to our paper discussions. We have very limited time. We have ICT parts, not easy. Okay, we have ICT parts. We have statistic not completed yet, and we have practical book එකක් තියෙනවා. We have practical book as well, and lot of paper discussions. Still we only start. Okay, therefore this remain 6 to 7 months is not easy, but amount of you working that your result mainly depend on your working amount within this 6 months. Actually, this is the one and only an exam in your words in your life in you facing. Your working amount is directly proportional to directly equal to your result. Okay, working කොච්චර වැඩ කරනවද, that is your result. Okay, not like O level. In O level exam, even final month, if you focus very well into all subjects, you can get good result for all subjects. Okay, but it is not this exam is not like this. Okay, now these questions you can understand if you after we discussed past paper discussions, you can understand always the professors. Normally this exam paper, A-level papers are made by paper panel with qualified professors. Are they not school teachers? Not school teachers. Normally O-level papers made by school teachers. Therefore, always A-level paper has some standard level. Okay, standard level and thinking pattern. If you need good result, you have to work into this level and you have to improve up to this level, thinking level. If not, you can only get 50 marks. You can get without practicing 50 marks. Okay, but if you need more than 50 marks, C or B or more than A result, more than 75 marks, definitely you have to practice and work this final 6 months consistent. Okay, let's start electricity next week. Goodbye.